Hello and welcome again to another physics program. But the next 3 or 4 physics programs are going to deal very specially with topics which you have to know for your upcoming Class 10 examinations. And in this program, which will be quite a short program, I want to talk about current flow and an electron flow in an electric circuit. Now, I've drawn a very poor drawing here of a simple electric circuit with a switch, a bulb, and a battery. And you will know that the short line of a battery is the negative side and the long line is the positive side. Now, if you have any difficulty in remembering which is positive and which is negative, think about this. There's a negative sign, a short line. Here's the positive sign, and if we think about it, there are 2 lines there, one that way, one that way. If you separate them and put them end on, they'll end up as a long line. So the positive sign is the long line, the negative sign is the short line. So an easy way to remember which is the positive and which is the negative in a battery symbol. Now, you will know that in order to make this bulb light, you have to close the switch to create a complete electric circuit. If the circuit isn't complete, if I opened that switch, the bulb will not light. Why not? Because electricity is a flow. Electricity flows around. And just as if you had a broken water pipe, your water wouldn't flow, so also if this circuit is broken, no electricity flows, the bulb doesn't light. So let's close the switch. Now the bulb is alight. And what's happening? Well, you will be told that electric current is flowing from the positive terminal of the battery around the circuit, through the bulb, and through the switch, and back to the negative terminal of the battery. In your textbook and your teacher, they will both have told you So here's a simple electric circuit, current flowing from the positive terminal of the battery through the bulb and the switch and back to the negative terminal of the battery. The current flow I've shown with black arrows. Now, let's have a look at a little circuit I've made here with a little kit. And I've got exactly what I show on the board. Switch. Connecting. The positive terminal of the battery is here. This is the positive terminal. Now, the bulb is not alight because the switch is not closed. So I shall close the switch, and with luck, the bulb lights, just as if it was a torch. The current is now flowing round the circuit from the positive terminal of the battery through the switch, through the bulb, and round back to the negative terminal of the battery. An absolutely simple, basic circuit. Imagine the current flow. You can think of the current flow as like the flow of water in a pipe. As I said a moment ago, if I break the water pipe, the current cannot flow anymore, so the bulb does not light. You can think of it like the flow of traffic around a circular road, the flow of traffic around a roundabout. So electric current is a flow. But in a minute, I'm going to say what is flowing, what is moving. Before I come to that, the current's flowing that way, because this is the positive terminal of the battery. I can take something which only allows the current to flow in one direction. If I put it there, the current is flowing through the light-emitting diode back to the negative terminal of the battery. But watch what happens. If I take this and turn it round so that now the current is trying to flow that way through it, but I've turned this round so it's flowing backwards, the bulb does not light because this is a device called a diode which only allows current to flow in one direction. It will only allow current to flow one way, and this way round the current cannot flow. I could do the same thing by turning the battery around. If I unclip here and here, and remember this is the positive terminal of the battery just here, that's negative. If I turn the battery round, then I've reversed the direction of current. Now, this is the positive terminal of the battery. The current is trying to get from there through there, but it won't go because this only allows current to flow that way. It won't go that way, and therefore the bulb doesn't light up. That's called a diode. If I reverse the diode, it will light up. So a diode only allows current to flow one way. Let's take another little device, an electric motor. Ooh, that went off all by itself. Let's undo the switch. And if I put the electric motor there, and I put a little fan on so that I can see which way it goes, remember now this is the positive terminal of the battery, this is the negative. The current is flowing that way round when I close the switch, observe which way the motor goes. Watch the fan. It's going that way. The current's flowing round there like that, and the fan is going round like that. What do you think will happen if I change the direction of the current flow? At the moment it's going from positive round through to negative. Now let's turn it round with the batteries by changing the battery direction. And now this is the positive terminal of the battery. Before it was there, now it's here. When the positive terminal was there, current was going that way, but now I've turned the battery round, positive to negative. What do you think the electric motor will do? Will it not work like the diode, or will it work? Well, it works. But what do you notice? It's now going round this way. So if I reverse the direction of the current in the electric motor, the direction of the motor changes. Jolly useful in an electric car, where I can make the car go forwards, or by changing the direction of the current flow, make it go backwards. So I want you to think about the current flowing. And now I'm going to ask the question, what is actually flowing through these wires and through the electric motor. And here we come to a bit of a confusion. When electric current was first discovered, scientists did not know what it was going through the wires. They knew something was going through the wires, but they didn't know what. And so they invented this phrase, electric current. And they realized that it was different whether it went this way or whether it went that way, and so they simply said, without understanding why, let's say that the current goes from the positive terminal of a battery to the negative terminal. They didn't understand what was happening, and in fact many scientists 60 years ago thought that electricity was like water. It was a sort of a fluid that flowed through the wires. And they said it goes from the positive to the negative. However, when we learned a little bit more about electricity, and after the electron had been discovered, people realized that what was flowing was electrons, that electrons were actually moving through the wires and through the motor. The problem is, the electrons were not going from positive to negative, they were going from negative to positive. And so we have this confusion. And I hope your textbooks and your teachers explain it well, that electric current goes one way, but what's actually moving is electrons which have a negative charge. Negative is repelled by negative, so they go from the negative terminal of the battery around through the wires like that, the opposite direction to the current flow. Board writer, if I wanted to show the electron flow goes from the negative back to the positive. Negative electrons are repelled by the negative end of the battery and attracted by the positive end. So we have this slight difficulty. Current flow is what we normally talk about, from positive to negative, but what's actually moving in the wires are electrons, which go from negative to positive. And let's look at how that happens by looking at a game of Chinese checkers. And yesterday I bought this Chinese checkers set in Hong Kong market, and we'll look at it in a moment. The difference between the direction that the current flows from the positive terminal of the battery to the negative terminal, so the current is flowing that way, but the electrons are flowing in the opposite direction. So what is this current business? And isn't it a bit confusing that you're told current's going like that, but what's actually moving are electrons that way? How can we explain that? Well, I've got here a Chinese checkers board and a whole lot of little balls there, but you'll notice there is an empty space. There is a hole there. Now, watch what happens. If I start moving the balls that way, watch what happens to the hole. 1, 2, 3. The hole has now moved from there to there. Watch the hole. Which way are the balls moving and which way is the hole moving? The balls have moved that way, but the hole has moved that way. It's just like electron flow and current. What do the balls represent? The balls represent electrons. And you know that normally an atom has an equal number of positive charges and negative charges. The positive charges on the nucleus of the atom and the electrons going around the outside. So if we're going to think of these as electrons, we can think of the hole there as a positively charged atom, a positive charge. I move an electron there, it cancels out the positive charge, and that becomes neutral, but the positive charge is now left on the atom that lost that electron. So the positive charge has moved from there to here. Move that electron, now the positive charge has moved to there. And if I move the electrons to my right, the hole, or the positive charge, moves to the left. And that is just like electron flow and current flow. The direction of the current flow is the direction that positive charge moves. And so think of our electrons. This is the positive terminal of the battery. The electrons are moving this way. If I put my little circuit up here, you can think of the electrons moving this way. But that means positive charge is moving that way. So the current is the direction of movement of the positive charge from the positive terminal of the battery around there like that to the negative terminal. But what's actually moving are the electrons. Just like I moved the little balls here to represent electrons, the electrons are moving that way, but as they move, they cause the positive charged atoms to move round that way. The atoms don't actually move themselves. If they did, the whole of the wires and everything would start moving. It's just that positive charge moves that way. So when you learn that current flows one way, but electrons flow in the opposite direction, this is what's happening. Remember the Chinese checkers board. I move the electrons to my right, but the little hole that's left when I move them moves the other way to the left. So I'll repeat. The current, positive charge, goes that way. The electrons are actually flowing that way. Now, you may ask yourself, why make it all so confusing? Why don't we just say that the direction of the current is the direction that the little balls move in, that the direction that the electrons move in? And it's a historic reason. Because when electric current was first discovered, nobody knew what was moving. In fact, in the beginning, and by the beginning I mean sort of 70, 80 years ago, people thought that electric current was a bit like water. They thought of electric current as a fluid that flowed through the wires. They didn't understand that what was happening was the electrons were moving. And so somebody said, oh, well, let's just say that this electric liquid, this electric fluid, flows from the positive to the negative. They had no reason for saying that. It's just somebody decided that would be the way it would go. And then later on, when they realized that what was happening was that the electrons were moving, the trouble is that everybody got used to saying the current flows from the positive to the negative, All the textbooks, that's what it said. All the arrows on circuit diagrams, that's what they showed. And so nobody could be bothered to change it. So we're stuck with this little confusion that the current flows from the positive to the negative terminal of a battery. That's the direction of current flow, but actually what is moving are electrons going in the opposite direction. It's quite obvious, isn't it, that the positively charged atoms that are left, if I take away an electron from an atom, the positively charged atoms can't move because they are what make the material of the wires. If they moved, the whole of the circuit would move around, whoosh, just like that, and that doesn't happen. So, I hope that helps a little bit to explain the difference between the direction of flow of a current and the direction of flow of the electrons. Now, if we're dealing with a battery and a bulb, it's quite all right not to worry about the electrons. We just think about current flow. But the time when we have to start thinking about the electrons moving is when we get into electronics. And this is where electronics is special, because electronics is all about controlling the flow of the electrons. Let's finish with our circuit diagram that you may see in your textbook or in an exam paper. Battery, switch, bulb. The electric current flows from the positive terminal of the battery in the direction of the black arrows and through back to the negative terminal of the battery. That's the way the current flows. But what is actually moving are electrons which flow in the opposite direction. The electrons flow in the opposite direction to the current flow, like that. So electrons are actually repelled by the negative terminal of the battery. Remember, like charges repel, and they're attracted by the positive terminal of the battery. Current flow, electron flow. So don't let yourself get confused by that. And remember, I mentioned at the very beginning, you can remember which is the positive and which is the negative terminal of the battery, because the symbol for negative is just one short line. Positive is two lines crossed. Put the two lines end on and you get a long line. So the short terminal of the battery is negative. The long terminal of the battery, made up of two lines, is positive. So in the next program, we'll look at something where electron flow is very important, and that is the cathode ray tube, how it's made and how it works.